Ole Andreas Alsos at NTNU again, this time with the title Designing Shore Control Centers in the Age of Autonomous Ships, the case of a shore control lab.
We built the shore control lab at Nyhavna in Trondheim to control the milliampere 2. At this research facility we simulate different operational scenarios. We can monitor or take over and remotely control our autonomous research platform, the milliampere 2. The lab allows us to test ideas before we go into the wild. In this way we monitor how people behave and perform under different working conditions. Trust between humans and autonomous systems is at the core of the Trust project. Additionally, the user's perspective and perception play a significant role in the introduction of autonomous ships. One of the activities was to test the VR simulation of an autonomous ferry ride on a canal using the milliampere 2 prototype. Rails, seats and masts were built in full scale to enhance the authenticity of the simulation. Now you were able to touch what you saw. In a secure environment it was possible to evaluate how individuals perceive and respond to various events by using simulations.
Here is milliampere 2, one of the world's first autonomous passenger ferries for urban waterway transport. What you see now is a team of a citizen panel boarding the ferry. Here you see it in operation in Trondheim. And here you see a real autonomous docking of the ferry. The tent you see on board is only to protect computer equipment, and it will be removed during nice weather and real operation. Hi, and welcome to this presentation about the NTNU Shore Control Lab and how to design shore control centers in the age of autonomous ships. My name is Ole Andreas Alsos, and I'm an associate professor in interaction design and head of NTNU Shore Control Lab. I'm from Department of Design at the Norwegian University of Science and Technology. And as highly automated ships become unmanned, their operators will move into shore-based control centers. And in the last years, NTNU has built an advanced and flexible research infrastructure for performing research on autonomous ships and the monitoring and control of these. We are part of several projects related to maritime interaction design, where the largest project is the SFI AutoShip, a center for research-based innovation for the development of autonomous ships for safe and sustainable operations. This is the overall picture of the infrastructure. It consists of a control room, a researcher lab, an observation room, and various prototypes of autonomous urban passenger ferries, and also a land-based terminal. We also have infrastructure for data and video storage and sensors on board the ferry, both for autonomy and for operator and passengers. First, the shore control lab itself. It consists of 3 rooms, 1 control room, the observation room and the instructor station, as well as a reception area. It is located in Trondheim, and as you can see, it's a distance between the mAh2 crossing and the shore control lab and the mixed reality lab. The control room of various screens and computer equipment for 2 operators and allows for a flexible setup. This means that we can have different kinds of applications and domains involved here. Here is an example of a prototype where 2 operators operate up to 8 ferries in the Trondheim city. The research lab is a place where we as researchers can sit and monitor the operators and what they are doing in the lab. With a lot of different camera equipment inside the lab, we can monitor what they are doing and also monitor the stress level and cognitive load. Here you see an example of what we can see from the lab. By equipping the operator with the eye tracking glasses and equipment for monitoring stress, such as galvanic skin response and heart rate, we can get an impression of their stress level and cognitive load. In the observation room, stakeholders such as developers, project managers, product owners, team leaders and other stakeholders can sit and monitor experiments going on in the lab. Here you see people in the observation room observing through a screen or through the windows what's going on in the control room. mAh2 is one of our ferry prototypes. With this we can try out different things related to sensors and also passenger experience. We have already tried the ferry on passengers, a panel of real passengers, and the ferry itself has a lot of sensor for autonomous navigation, ranging from RGB cameras, up 8 RGB cameras, 4 infrared cameras, LiDAR, 2 LiDARs, and ultrasonic sensors, in addition to a radar, and also different kinds of radio communication and 4 and 5G connection. The mixed reality lab is a tangible VR simulator where we have built a full-scale model of mAh2, and by putting VR goggles on the passengers, they can try out the ferry almost as in real life, very realistic, and they can walk around on the ferry, hold on the handrails and sit on the bench while experiencing a ferry trip with crossing traffic and other passengers on board. The AutoFerry Gemini simulator is a digital twin of mAh2. With this, we can test out different scenarios and we can let the operator try out the ferry without the danger of being on a real ship. Here we can test out different tail events without risking equipment and passenger. These 3 ferry prototypes of different fidelity let us test out different things and is a great part of our research infrastructure. With the 3 different prototypes, we can try out different things related to explainable AI and automation transparency. The last part of the research infrastructure is the land-based terminal. We are currently building a dock with induction charging that allows us to try out passenger flow and automatic charging of the ferry. Here is another example of the dock concept. We are currently working on how to put the entire ferry into a service, and we look at different things such as the mental model, how to communicate with the passengers, safety, giving feedback to the passengers, and whether it has seen the traffic around me. All in all, the Shore Control Lab infrastructure allows us to do research on autonomous ships and the remote monitoring and control of them. Thank you very much.
Thank you for the presentation. Do you have any questions from the audience? No questions at all? I guess I've been so much involved in what you are presenting myself that I shall not ask any questions. There was a question here from Alan McGee. I can repeat that. What is the future development? You want to say anything more?
Yes, I can tell you more about our future plans for the Shore Control Lab. First of all, we think that together with the control room and the ferry gives us an excellent research infrastructure for doing all kinds of research. So for the mAh2, our next step is to equip it with different kinds of sensors, not for the autonomy, but for the operator situation awareness, and also to provide the passengers with some kind of feedback on what the ferry is thinking. And we're also equipping the ferry with the LEDs and other kinds of actuators that can provide the environment, other ships and bystanders with information about their state and future intention. In the lab, we are also equipping the lab with the actuators to provide the operator with a better situation awareness, so that they can easily monitor and take over control of the ferry when needed, so that they can get a good view of what's going on the ferry and outside the ferry, and that they can actually hear what's going on around them. They can hear kayakers shouting or passengers that are worried or whatever. And also two-way communication between the operator and the passengers. We are also working hard on the land-based terminal right now, so that the passengers can order it on demand and give the passengers feedback about its state and intention. So we have a lot of different plans, but right now we are using it for various experiments on operator situation awareness and passenger trust. And I can also mention that the lab was developed using a user-centered process with a lot of different stakeholders. So we had a real design process with both the professional researchers, people from the industry, architects, and industrial designers involved in the process.
I would perhaps be tempted to add myself to some of what you said, that I think one of the big challenges here is that we must remember that when we talk about autonomy, both the ship and the operator will each have different situational awareness. and for the ship to convey the situational awareness to the operator and vice versa. I think that is one of the core challenges, because it requires you to dissect, so to dig into the algorithms that you are using in the automatic situational awareness, and whether or not that is model-based methods or it's some neural networks, that is not trivial to make sure that the operator actually gets the information that the ship is using to make its decisions.
Yeah, thank you very much, Edmund. And you're onto something important here, that operators and the autonomous ship will kind of operate in a team. We have seen several talks about it earlier this morning. And there was a question yeah.
Hi, thank you so much for that talk. It was insightful. I'm Mayank from the Center for Maritime Law. My question was, like you said, there have been other talks about acceptability before, but with respect to this particular talk of yours, how much would the seafarers or the operators be okay with, sort of these sensors near their eyes, and basically how much would they be okay with giving this information about their bodies or about their expressions and reflexes to the shore-based controller? Is that something that has been considered?
Yes. First of all, the eye tracking and then galvanic skin response and the heart rate is only used during experiments. And remember, the purpose of the lab is to find out what is the best user interface and setup for these control rooms. For operational control rooms, we will probably not use eye tracking and stress indicators. So the purpose of our lab is to find out how to design the best, safest possible control room for operation.
Right, but in that case, let's say that a maritime autonomous ship is in operation. Obviously, the public perception for a ship that has no crew on board is going to be quite high with respect to the risk factor. So in that case, do you believe it is important that the operator is somebody whose fatigue, whose stress, and whose essentially all these, personal expressions and intuitions, those be tracked so that there is not a risk of collision or a risk of grounding or something adverse?
Little
That
bit
was a very
short
good
on time,
point.
so quick answer to that one.
Very good point. First of all, I think that on board a ferry there will be a safety host for a period of time until people are used to it. And I think that designing for trust is an important research topic in the future. How can we design the ferry so that people will board it and trust it? And I think that several operators need to operate a fleet of ferries, and they should take care of each other and be able to take over if someone is tired or fatigued.
Right, thank you.
Okay, thank you again for the presentation.